if in fact we want to go from the number of...
Can I go back to that? Because it seems like if you've got 4 columns, you've got 4 factorial over, and then the number of columns you want to be unique, right? So is it 4 factorial, and then if you'd have shifted the line over to the left one and you'd have wanted to know how many unique combinations of the first 2,
Right.
you'd be doing just 4 factorial over 2 factorial? Is that kind of, and then as the numbers get bigger, you're really just kind of dividing things out? Is that kind of a way to look at that?
Well, if you're counting the number, you have to actually count the number of ways you can organize the permutations when you do care about order, and then you have to count the number of ways the subgroups are going to show up. Because otherwise it's going to get confusing, at least for me.
Okay.
So to answer your question, you know, well, try to answer your question. I'm not sure exactly how to answer your question because it's not clear to me what you're asking. I know, sorry. I have to, and I know it's not clear to you what I'm saying. It's just, if I keep trying to say it in the same consistent way.
It's like you've got this thing that you did where you have the 4 total columns and you're trying to do the total number of permutations.
Okay.
And now you're going to do the total number of permutations where only the first 3, or where
Well, let's do that. So we could have A, B, A, C, A, D, A, B, A, C. And that's about it, right? For A, starting with A. And then we've got B, C, B, D, B, A, C, D, C, A, C, B, D, A, D, 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 C. Are there any other ways to do that? 4 times 3, 12. 3, 6, 9, 12. Right. Okay, so there are 12 ways to do this. Everybody agree with that? Okay. Now, how many times does each group show up? You've got AB here, and you've got BA here. Each group of 2 shows up only twice. But when you count then the number of ways you can pick out groups of 2 when you don't care about order, you've got 12 divided by 2, which is 6. Did that help at all? Is that what you're talking about?
I think I'm more confused. I think I'll figure it out.
Excellent. My job is done. Well, I find this very confusing because it basically reassesses something we've already visited in kindergarten, that is counting. Okay, but by the same logic, yes.
715.
What's that?
715.
Oh, all right. Well, let me just finish the subject. We'll define 21, choose 4, and that's typically written like this, as 21, so the permutations divided by 4 factorial. Or in general, this. So here, what we're doing, well, let me write this out one more time. This is then 21 factorial over 4 factorial, 21 minus 4 factorial, or in general, the same one right here. So which has more, permutations or combinations? Or which of them are there more of?
Permutations.
Right. It's clear to everyone that if order matters, there are going to be more? Okay. One canonical example that I found useful when keeping this apart is, imagine all 21 of you are in an emergency room. And you have a triage nurse picking out 4. The triage nurse cannot assign, there are 4 different doctors, they're very different in specialties and skills, but the triage nurse is just picking out 4. So at this point, order does not matter. Which are we dealing with? Permutations or combinations?
Combination.
Combinations, right? But if we jump to assigning patients to separate doctors, how many ways could we pick out 4 that are assigned to specific doctors? Then we'd be dealing with permutations. And it's clear to everyone that we'd have a lot more ways of doing that. Yes?
Mhm.
Maybe? All right. Thank you. And let's take our break now and we'll continue